June 18, 1944, Northern Saipan, Mariana Islands. Major Koji Nakamura of the Imperial Japanese Army Technical Bureau walked slowly through the morning smoke, his boots crunching on spent shell casings and scorched earth. Around him lay the wreckage of the previous night's disaster, 31 Type 97 Chiha tanks, reduced to burning hulks, their crews dead. But it was not the Japanese tanks that held his attention. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Before him sat an American M4 Sherman, track thrown, hull penetrated by a 47mm anti-tank round that had struck the sponson at close range. The crew had abandoned it during the chaotic night battle. The tank was otherwise intact, its welded hull gleaming in the tropical sun despite the carbon scoring along its flanks. Nakamura had spent 15 years designing tanks at the Mitsubishi Heavy Industries facility in Nagoya. He had studied at the prestigious Tokyo Imperial University, had travelled to Europe to observe German and French tank construction, had personally overseen the riveting of thousands of armour plates on hundreds of Chiha tanks. He understood armour. He understood steel. He understood what he was looking at. This cannot be their standard construction method. No serious military would build tanks this way. The Sherman measured approximately 6 meters from nose to tail, sitting on its vertical volute spring suspension like a metal box. The hull, cast in some sections and welded in others, showed none of the precision craftsmanship Nakamura had devoted his career to perfecting. The welds were thick, crude, visible seams running along every joint. No attempt had been made to grind them smooth or disguise them. The armour plates appeared to have been cut quickly, fit roughly, and welded together with speed, prioritized over elegance. Nakamura climbed onto the hull, his hands running across the welded seams. The armour thickness measured approximately 50 millimeters on the frontal glacis, sloped at 56 degrees. Adequate protection, certainly better than the 25mm plates on his Chiha, but the construction quality was abysmal. The welds showed spatter marks, incomplete penetration in places, obvious signs of rapid production with minimal quality control. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. He opened the driver's hatch and descended into the interior. The smell hit him immediately, a mixture of gasoline, oil, sweat, and the distinctive American odor he had noticed in captured equipment, something chemical, perhaps from their cleaning products. The interior was spacious, surprisingly so. The Chiha required its commander to also serve as gunner, cramming 2 jobs into one position. This Sherman had dedicated positions for 5 crew members, each with adequate space to perform their specific role. But what stunned Nakamura was the utter lack of refinement. The interior panels were welded steel, no sound dampening, no vibration isolation, no attention to crew comfort beyond the bare minimum. Electrical wiring ran exposed along brackets, labelled in English with tags that appeared mass-produced. The instruments were simple, large, easily readable, designed for rapid replacement rather than long-term reliability. This was not a tank designed by engineers who cared about their craft. This was a tank designed by factory managers who cared about production numbers. Nakamura had brought 2 junior engineers with him, Lieutenant Takeshi Yamamoto and Sergeant Ichiro Suzuki, both graduates of the Army Technical School. They were now examining the turret, their voices carrying in the tropical morning air. "Major, you should see this gun." "Mounting," Yamamoto called out. "The entire system is welded, not a single bolt on the primary structure." Nakamura climbed up through the turret basket, emerging into the fighting compartment. The 75mm M3 gun dominated the space, its long barrel extending through the mantlet. Yamamoto was correct. The gun mount, the turret ring, the internal brackets, everything was welded. In Japanese tank design, critical load-bearing components were riveted, allowing for field replacement and repair. Welding created permanent joints that could not be easily serviced. "They must replace entire assemblies," Nakamura observed. There is no provision for field repair of welded components. Perhaps they do not expect their tanks to require repair, Suzuki suggested. The comment hung in the air. They all understood the implication. The Americans built tanks expecting to replace them, not repair them. This represented a fundamentally different philosophy than Japanese engineering, which emphasized durability, repairability, and long service life. The journey to this moment had begun not on Saipan, but in the design bureaus of Tokyo and Nagoya in the 1930s, when Japanese engineers believed they understood how modern tanks should be constructed. Major Tomiohara, who would later rise to general, had pioneered Japanese tank design in the 1920s. Working with minimal industrial infrastructure and even less experience, Hara and his team had looked to Europe for inspiration. They studied British Vickers designs, examined French Renault tanks, absorbed German engineering principles. What they learned emphasized precision, craftsmanship, and quality. European tank construction in the 1920s and 30s utilized riveting as the primary method of joining armor plates. Rivets allowed for controlled assembly, permitted thermal expansion and contraction, and could be replaced in the field if damaged. The technique required skilled craftsmen who could heat rivets to precise temperatures, position them correctly, and set them with proper force. Each rivet represented individual attention, individual quality control, individual pride in workmanship. Japanese engineers embraced this philosophy completely. When the Type 89 Chiro medium tank entered production in 1929, every armor plate was riveted. When the Type 97 Chiha replaced it in 1938, the design continued the riveted construction tradition. Nakamura himself had supervised riveting crews at Mitsubishi, watching skilled workers position each rivet, heat it cherry red, and set it with pneumatic hammers. The process was slow, labor-intensive, and expensive. But it produced tanks of exceptional build quality. The Type 97 Chiha represented the pinnacle of Japanese tank engineering philosophy. The hull was constructed from multiple armor plates, each cut to precise specifications, each edge beveled exact angles, each rivet hole drilled to tolerances measured in fractions of millimeters. The riveting crews worked in teams, coordinating their efforts to ensure even pressure distribution across every joint. The finished product was elegant, refined, a testament to Japanese industrial capability, but it was also slow to produce. A single Chiha tank required approximately 8,000 rivets. Each rivet needed individual heating, positioning, and setting. Even with experienced crews, hull construction alone required days of labor. Complete assembly from raw materials to finished tank took weeks. By 1943, Mitsubishi's Nagoya plant was producing approximately 40 Chiha tanks per month at maximum capacity. The Americans were producing 40 Sherman tanks per day. Nakamura had received the intelligence reports. He had read the numbers multiple times, certain there must be an error. The Chrysler Detroit tank arsenal alone was producing 500 Sherman tanks per month. The Fisher Grand Blanc plant in Michigan, another 500. American Locomotive Company, Baldwin Locomotive Works, Pressed Steel Car Company, Pacific Car and Foundry, all producing Shermans in numbers that seemed impossible. By mid-1944, American factories had produced over 30,000 Sherman tanks. Japan had produced approximately 2,000 Chiha tanks over 6 years of production. The disparity was not merely significant, it was absolute. It represented two completely different approaches to industrial warfare. The Sherman, before Nakamura, represented that American approach made physical. Every design decision prioritized production speed over craftsmanship. The hull was welded because welding was faster than riveting. The welds were crude because finishing them wasted time. The components were standardized because standardization enabled mass production. The entire tank was designed not to be perfect, but to be built quickly in enormous numbers. This philosophy was alien to Japanese engineers. Nakamura had been trained to believe that quality was paramount, that each tank represented the honor of its builders, that craftsmanship demonstrated national character. The Sherman contradicted every principle he held. Yet the Sherman was here, on Saipan, thousands of kilometers from American factories, and the Chi-Ha tanks that had attacked it were burning wrecks. The tank battle of June 16 to 17 had been a catastrophe for Japanese forces. Lieutenant General Yoshitsugu Saito, commanding the 43rd Infantry Division on Saipan, had ordered a major armored counterattack to drive American Marines back into the sea. The 9th Tank Regiment, Colonel Takashi Goto commanding, assembled 36 Type 97 tanks for the assault. The 136th Infantry Regiment contributed additional Type 95 Hargo light tanks. Together, they represented nearly the entire armoured strength on Saipan. The attack began at approximately 11:30 p.m. on June 16. The Japanese tanks advanced in column down the coastal road toward Charankanoa, where American Marines had established their beachhead. The plan called for the tanks to break through American lines under cover of darkness, reach the beaches, and destroy supply dumps before Marines could organize effective resistance. The plan failed within minutes. American Marines, veterans of previous island campaigns, had prepared defensive positions specifically to counter tank attacks. 37mm anti-tank guns covered every approach. Bazookas were distributed throughout infantry companies, but most devastating were the M4 Sherman tanks of the 2nd and 4th Marine Tank Battalions, positioned in hull-down positions with clear fields of fire. The Japanese tanks emerged from darkness into killing zones illuminated by star shells fired from offshore destroyers. The Marines opened fire at ranges exceeding 1,000 meters. The Sherman's 75mm guns could penetrate Chi-Ha frontal armor at these distances with ease. The Japanese tanks' 57mm guns could not penetrate Sherman frontal armor at any range. The mathematics were brutal and one-sided. Sherman gunners reported that armor-piercing rounds passed completely through Chi-Ha tanks without detonating, the thin armor providing insufficient resistance to trigger the fuses. They switched to high-explosive rounds, which proved devastatingly effective. The HE shells struck Chi-Ha hulls and detonated, the blast effect shattering riveted armor plates and killing crews instantly. By dawn on June 17, 31 Japanese tanks were destroyed. Approximately 200 tank crew members were dead. The survivors retreated in disorder. American casualties included 5 tanks damaged, quickly repaired and returned to service within hours. Nakamura stood among the wreckage now, 2 days after the battle, surveying the physical evidence of industrial disparity made real. The destroyed Chi-Ha tanks showed a consistent pattern. Hits to the hull caused rivets to fail, armor plates to separate, and internal spaces to fill with fragmentation. The rivets themselves became projectiles, tearing through crew compartments like shrapnel. What Japanese engineers had considered quality construction proved to be a fatal vulnerability. He walked to the nearest destroyed Chi-Ha, number 317 from the 5th Company. The tank had taken a direct hit to the turret, the 75mm HE round detonating against the riveted plates. The explosion had blown every rivet from the turret face, the armor plates separating and collapsing inward. The crew inside had been killed instantly, not by the shell itself, but by hundreds of rivets transformed into supersonic projectiles. This was the cost of craftsmanship in modern warfare. Nakamura climbed back into the abandoned Sherman and sat in the gunner's position. From here, American tankers had methodically destroyed Japanese armor. The gun sight was simple, marked with range graduations in yards, designed for rapid target acquisition. The gun controls were mechanical, reliable, requiring no finesse. The ammunition racks held 69 rounds of 75mm ammunition, each round identical, mass-produced, interchangeable. Everything about this tank screamed mass production. The armor was adequate, not excellent. The gun was effective, not superior. The mobility was good, not exceptional. But none of that mattered, because there were 40 Sherman tanks produced today, and 40 more tomorrow, and 40 more the day after that. Quality meant nothing against quantity of this magnitude. Lieutenant Yamamoto appeared at the turret hatch. "Major, We've examined 3 more Sherman tanks abandoned on the beach. All show the same construction methods: welded hulls, crude finishing, standardized components. We believe this is their universal production standard, not an aberration. Nakamura nodded slowly. He had reached the same conclusion, though he had resisted accepting it. The Americans had abandoned European craftsmanship entirely in favor of industrial efficiency. They had sacrificed quality for quantity, elegance for speed, refinement for production capacity, and in doing so, they had created a weapon system that Japan could not counter. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The realization was devastating in its simplicity. Japan had approximately 60,000 skilled metalworkers capable of producing tank-quality riveted armor. Training more required years. Riveting equipment was expensive and complex. Production facilities were limited by the availability of trained craftsmen. Even if Japan tripled its tank production, it would still produce only several thousand tanks per year. America had millions of factory workers. Welding could be taught in weeks. Welding equipment was relatively simple and cheap. Production facilities were limited only by the availability of steel and factory space. American automobile plants, designed to produce thousands of cars per month, had been converted to produce tanks at similar rates. This was not a contest Japan could win through superior engineering. This was industrial warfare on a scale Japanese planners had never imagined. Nakamura requested permission to conduct a comprehensive technical evaluation of the captured Sherman. His report would be distributed to the Army Technical Bureau, to Mitsubishi Heavy Industries, and ultimately to Imperial General Headquarters. The findings would shape Japanese tank development for the remainder of the war, though by June 1944, such development had become largely theoretical. Over the following 3 days, Nakamura's team dismantled portions of the Sherman, documenting every aspect of its construction. They measured armor thickness at multiple points, finding variations of up to 3 millimeters between supposedly identical plates. In Japanese production, such variation would be considered unacceptable. In American production, it was apparently standard practice, the variations falling within tolerances that prioritized speed over precision. They examined the welding in detail, cutting sections of hull to analyze weld penetration and quality. What they found was simultaneously impressive and disturbing. The welds were not beautiful. They showed irregular penetration, inconsistent bead width, and minimal finishing. But they were structurally sound. The Americans had determined the minimum weld quality necessary for structural integrity and produced exactly that, nothing more. They have calculated the acceptable margin of error, Sergeant Suzuki observed, studying a cross-section of hull weld. These welds will hold under combat stress, but they waste no effort, making them prettier or stronger than necessary. This represented engineering philosophy fundamentally opposed to Japanese tradition. Japanese craftsmen took pride in exceeding minimum standards, in producing work of higher quality than strictly required. The concept of deliberately producing to minimum acceptable standards was alien, almost offensive, yet it was also brutally efficient. The Sherman's cast armor sections revealed similar principles. American foundries were producing cast armor components at rates Japanese foundries could not match. The casting quality was adequate, showing some porosity and inclusion defects that Japanese metallurgists would have rejected. But the Americans accepted these minor flaws, recognizing that perfect castings took longer to produce than adequate castings, and adequate castings provided sufficient protection. Nakamura documented the engine compartment with particular interest. The Sherman before them mounted a Chrysler A57 multibank engine, an engineering monstrosity created by arranging 5 automobile engines around a common crankshaft. The configuration was complex, difficult to maintain, and represented everything Japanese engineers considered poor design. Yet it worked. The A57 produced 425 horsepower reliably. More importantly, it utilized existing automobile engine components, allowing Chrysler to produce tank engines without developing entirely new designs. This was the American approach distilled to its essence: use what exists, modify minimally, produce quickly. Japanese tank engines, by contrast, were purpose-built designs. The Mitsubishi Type 97 diesel engine in the Chi-Ha was specifically engineered for tank use, with custom components designed from scratch. It was more efficient, more refined, and far more expensive than adapting automobile engines. It also required specialized manufacturing facilities and could not be produced in automobile factories. The Americans had converted automobile plants to tank production in months. Japan could not replicate this approach because Japanese tanks used components that automobile factories could not produce. Nakamura compiled his findings into a comprehensive technical report, completed on June 22, 1944. The report ran to 47 pages, with detailed technical drawings and metallurgical analyses. But the core conclusions could be summarized in a single, devastating paragraph. The M4 Sherman medium tank represents an approach to armored vehicle production fundamentally different from Imperial Japanese Army design philosophy. American engineers have prioritized manufacturing efficiency over engineering excellence, accepting reduced quality standards in exchange for overwhelming production capacity. The result is a tank inferior in individual quality to the Type 97 Chi-Ha, but produced in quantities that render Japanese qualitative advantages irrelevant. Recommendation: Imperial Japanese Army must immediately transition to welded hull construction and simplified design to increase production rates, though such transition cannot address the fundamental disparity in industrial capacity. The report reached Tokyo in early July. By then, Saipan had fallen. The island's capture placed American B-29 bombers within range of Tokyo itself. The strategic situation had deteriorated beyond recovery, but the report still circulated through engineering bureaus, where it generated reactions ranging from disbelief to despair. Commander Shigeo Otake, chief engineer at the Army Technical Bureau, read Nakamura's report with growing dismay. Otake had spent 20 years in military engineering, had designed or supervised production of virtually every Japanese tank since the Type 89. He had genuinely believed, that Japanese engineering excellence would compensate for limited industrial capacity. The captured Sherman proved otherwise. Otake called a meeting of senior engineers to discuss the implications. The meeting, held on July 15th in a Tokyo conference room, became heated quickly. "This is American propaganda," insisted Colonel Hiroshi Iwakuro, director of the Osaka Army Arsenal. No military would deliberately produce equipment to minimum standards. This Sherman must be a prototype or training vehicle, not representative of their production models. Major Nakamura examined multiple vehicles. Otake responded. All showed identical construction methods. This is their standard. Then, their standard is garbage, Iwakuro snapped. Those welds would never pass inspection at Osaka Arsenal. The casting defects alone would justify rejection. And yet, Otake said quietly, those garbage tanks defeated every Chi-Ha on Saipan in approximately 2 hours of combat. The silence that followed was profound. Captain Jiro Tomita, a young engineer recently transferred from Mitsubishi, spoke carefully. Commander Otake, if I understand correctly, the Americans are producing crude tanks rapidly, rather than refined tanks slowly. But crude tanks that exist on the battlefield defeat refined tanks that exist only in limited numbers. Precisely, Otake confirmed. Then we have been fundamentally wrong about tank production philosophy for 15 years. The statement hung in the air. No one contradicted it. The meeting continued for 3 hours, as engineers grappled with implications that undermined their professional identities. They had dedicated careers to perfecting tank design, to advancing Japanese armor technology, to creating vehicles that demonstrated Japanese industrial capability. The Sherman represented everything they had been trained to despise: crude, ugly, mass-produced mediocrity. But it worked, and there were tens of thousands of them. Some engineers rejected the implications entirely. Colonel Iwakuro would continue insisting until war's end that Japanese craftsmanship represented superior engineering, that American production methods were temporary expedients that would fail under prolonged warfare. Others recognized the truth immediately and began advocating for wholesale changes to Japanese tank production. The most insightful response came from Major General Tomio Hara himself, now serving as director of the Army Mechanization Headquarters. Hara had pioneered Japanese tank development, had personally designed the bell crank suspension system used on most Japanese tanks, had devoted his career to armored vehicle development. His response to the Sherman report was characteristically direct. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. We designed tanks for the war we expected to fight, Hara wrote in his analysis. Short, decisive campaigns, where quality would prevail. The Americans designed tanks for the war they are actually fighting. Long, industrial campaigns where quantity prevails. We were wrong. They were right. This understanding comes too late to change the outcome. Hara was correct. By mid-1944, Japanese industry was already faltering under American bombing and resource shortages. Even if Japanese engineers immediately adopted welded construction and simplified designs, even if they achieved American production efficiency, which was impossible given Japan's limited industrial base, the disparity in resources was too great to overcome. But efforts were made nonetheless. The Type 1 Chihei medium tank, designed in 1942, had already incorporated welded frontal armor instead of riveted construction. The Type 3 Chi-Nu, rushed into production in 1944 as a stopgap to counter Shermans, used welded turrets and simplified hull construction. The Type 4 Chi-2, Japan's most advanced wartime tank design, featured an all-welded hull. These design changes came too late, and in too limited numbers to affect combat outcomes. The Chihei entered production in 1943, with only 170 units completed before production ceased. The Chi-Nu saw approximately 166 units produced. The Chi-2 was essentially a prototype, with only 2 completed by war's end. Compare these numbers to American Sherman production. Between February 1942 and July 1945, American factories produced 49,324 Sherman tanks across 11 different plants. The magnitude of this production eclipsed not merely Japanese tank production, but Japanese comprehension of what industrial production could achieve. The captured Sherman on Saipan represented just one of those 49,000. It was expendable, replaceable, insignificant in the context of American production capacity. Yet, to Japanese engineers who examined it, this single crude tank demonstrated the futility of their entire approach to armored warfare. Back on Saipan, as Nakamura prepared to depart the island before its final fall, he took one last look at the Sherman that had occupied his attention for 3 days. American engineers would arrive soon to evaluate whether the tank was worth recovering. If not, it would be pushed into the sea or scrapped. There were plenty more where it came from. Nakamura had spent his career pursuing engineering excellence. He had believed, deeply believed, that superior design and meticulous craftsmanship would produce superior weapons. The Sherman contradicted this belief absolutely. It was not superior in design. It was adequate. It was not meticulously crafted. It was quickly assembled. But it was here, in overwhelming numbers, while his own beautifully crafted Chi-Ha tanks were burning wrecks. The Americans had understood something Japanese engineers had missed. In industrial warfare, adequate weapons produced in vast quantities will always defeat superior weapons produced in limited numbers. Quality was meaningless without quantity. Craftsmanship was irrelevant without production capacity. Engineering excellence was worthless without industrial might to back it. This realization spread through Japanese engineering circles slowly, reluctantly, painfully. It required engineers to admit that their careers had been based on false assumptions, that their dedication to quality had been misplaced, that their craftsmanship had been, in the context of total war, a liability rather than an advantage. Some never accepted it. Colonel Iwakuro continued advocating for riveted construction quality control until Japan's surrender, insisting that American methods were unsustainable. Others accepted it too enthusiastically, advocating for abandoning all quality standards in favor of maximum production, not understanding that the American approach still maintained minimum acceptable standards, just not the excessive standards Japanese engineers had previously insisted upon. The truth lay between these extremes. American engineers had not abandoned quality. They had redefined it. Quality meant fit for purpose and producible in necessary quantities, not exceeds all specifications, regardless of production implications. This was a subtle but crucial distinction that Japanese engineers, trained in a culture that valued perfection, struggled to grasp. The cultural dimensions of this engineering philosophy difference deserve examination. Japanese craftsmanship traditions, rooted in centuries of artisan culture, emphasized mastery through repetition, gradual improvement over time, and pride in work that exceeded minimum standards. A swordmaker who produced merely adequate swords was considered mediocre, regardless of quantity. Excellence required pursuing the highest possible quality. This cultural value system translated directly into industrial production. Japanese engineers believed that producing adequate equipment was shameful, that true professionals pursued excellence regardless of cost or production speed. This belief drove genuine technological advancement in areas where Japan competed successfully: optics, precision instruments, and specialized manufacturing. But in mass industrial warfare, this cultural value became a strategic liability. Wars are not won by small numbers of perfect weapons. They are won by overwhelming numbers of adequate weapons, deployed by well-trained forces with sustainable logistics. American engineers understood this implicitly. Japanese engineers learned it too late. The American approach to tank production reflected broader American industrial culture. The United States had pioneered mass production techniques with automobile manufacturing, beginning with Henry Ford's assembly lines in the early 20th century. American engineers were trained to think in terms of production systems, not individual products. Quality was measured not by how perfect a single unit was, but by how consistently acceptable units could be produced. This thinking extended throughout American military production. American rifles were produced to tolerances that allowed parts interchangeability across manufacturers. Japanese rifles required hand-fitting of components. American artillery used standardized ammunition that simplified logistics. Japanese artillery used multiple incompatible calibers that complicated supply. American aircraft used common engines across multiple airframe types. Japanese aircraft used specialized engines unique to each design. The pattern repeated across every category of military equipment. Americans prioritized standardization, interchangeability, and production efficiency. Japanese prioritized specialization, optimization, and engineering excellence. In peacetime, the Japanese approach produced superior individual weapons. In total war, the American approach produced overwhelming material superiority. The captured Sherman embodied this American philosophy completely. Its welded hull was crude because crude welds were faster to produce than beautiful welds. Its cast components had imperfections because perfect castings took longer than adequate castings. Its engine was a mechanical compromise because purpose-built engines required more development time than adapted automobile engines. Every design decision prioritized production speed and quantity over individual unit quality. Yet the tank worked. It was mechanically reliable, with American tankers routinely achieving operational readiness rates exceeding 80%. It was tactically effective, with the 75mm gun adequate for most combat situations in the Pacific. It was strategically decisive, with production numbers that guaranteed American armored superiority in every engagement. Japanese tank crews who survived encounters with Shermans reported consistent observations. The Sherman was not particularly fast, not particularly maneuverable, not particularly well armored by European standards. But it was always present in overwhelming numbers, always supported by effective logistics, always backed by industrial capacity that ensured damaged tanks were quickly replaced. This industrial backing was perhaps the Sherman's greatest advantage. American armored divisions knew that losses would be replaced. Tank commanders could accept risks that Japanese commanders could not, because destroyed American tanks would be replaced within weeks. Destroyed Japanese tanks were irreplaceable, each loss permanently reducing Japanese combat capability. The psychological impact of this disparity was profound. Japanese tank crews entered battle, knowing their vehicles were precious, irreplaceable assets that must be preserved at all costs. This encouraged cautious tactics, defensive positioning, and reluctance to accept losses, even when tactical situations favored aggressive action. American tank crews entered battle knowing their vehicles were replaceable components of a vast industrial system. This encouraged aggressive tactics, acceptance of calculated risks, and willingness to trade material losses for tactical gains. The Battle of Saipan demonstrated this psychological gap clearly. Japanese commanders initially refused to commit their armor, recognizing that lost tanks could not be replaced. When Lieutenant General Saito finally ordered the tank assault on June 16th, it was an act of desperation, not sound tactics. The attack was poorly coordinated, inadequately supported, and launched with no realistic prospect of success. Japanese tank crews knew they were being sacrificed, that their expensive, carefully crafted tanks would be destroyed, and that their deaths would not change the battle's outcome. American tank commanders, by contrast, positioned their Shermans aggressively, accepting that some would be damaged or destroyed, confident that the tank battalions would receive replacements. When Marine Shermans were hit and disabled, recovery vehicles towed them to beach maintenance areas where repair crews worked to return them to service. Damaged tanks that were repairable were fixed within hours or days. Tanks too damaged to repair were stripped for parts, with components used to keep other tanks operational. The entire system was designed for sustained operations with continuous losses and replacements. Japan had no equivalent system. Disabled Chiha tanks became permanent losses because recovery vehicles were scarce and repair facilities were limited. Replacement tanks did not exist in sufficient numbers. Spare parts were inadequate because Japanese production focused on building complete new tanks rather than producing spare components. Each disabled tank represented not just a tactical loss, but a permanent reduction in combat power. These systemic differences, more than individual tank specifications, determined the Pacific War's outcome. American industrial capacity could sustain losses indefinitely while maintaining offensive pressure. Japanese industrial capacity could not replace losses, forcing increasingly defensive posture and eventual defeat. The engineers examining the Sherman on Saipan understood this intuitively. The crude welds and rough castings they documented were not signs of American industrial incompetence. They were signs of American industrial confidence. Only a nation with overwhelming production capacity could afford to build tanks to minimum acceptable standards, secure in the knowledge that quantity would compensate for any individual deficiencies. Nakamura's final report included a section on implications for Japanese tank development that proved prophetic. He wrote, "The Imperial Japanese Army must recognize that conventional approaches to tank production cannot compete with American industrial methods. Even complete adoption of welded construction and simplified design cannot bridge the industrial capacity gap. Japan's limited steel production, restricted machine tool capacity, and shortage of skilled labor make matching American tank production impossible. Future Japanese tank development must therefore focus on specialized designs for homeland defense, accepting that offensive armored operations cannot be sustained against American material superiority." This assessment reached Tokyo as American forces consolidated control of Saipan. The island's fall placed B-29 bombers within range of Japan's home islands, making the strategic situation desperate. Tank development, never Japan's top priority given the Navy's dominance in military planning, became even less relevant as resources were diverted to air defense and homeland fortification. The Type 4 Chi-2 and Type 5 Chi-Ri tanks, Japan's most advanced designs, remained largely theoretical. The few prototypes completed served primarily to demonstrate what Japanese engineers could achieve given unlimited resources and time, neither of which Japan possessed. The tanks incorporated lessons from German Panther and Tiger designs, featured all-welded construction, mounted powerful 75mm guns, and represented genuine engineering advancement. But they were irrelevant. By late 1944, when these designs reached prototype stage, Japan had already lost the war. American bombers were systematically destroying Japanese industrial capacity. The steel required to build advanced tanks was unavailable. The factories capable of producing them were being bombed. The skilled workers were being drafted into desperate infantry formations for homeland defense. The Type 3 Chi-Nu, a simpler stopgap design, saw limited production for homeland defense. Approximately 166 were completed and stationed in Japan to defend against the expected American invasion. They never saw combat, remaining in defensive positions, until Japan's surrender in August 1945. The irony of Japanese tank development became apparent only in retrospect. Japanese engineers had pursued quality when they needed quantity. They had refined designs when they needed simplified production. They had crafted individual excellence when they needed mass production. Every instinct, every training principle, every cultural value had pointed them in precisely the wrong direction for the war they were actually fighting. This was not stupidity. This was the inevitable result of cultural assumptions meeting unexpected reality. Japanese military planners had studied European warfare in the 1920s and 30s, observing tank battles where quality and crew training determined outcomes. They had fought in China through the 1930s, where their tanks encountered minimal opposition and individual superiority proved decisive. They had concluded, reasonably based on available evidence, that producing the best possible tanks in limited numbers represented sound strategy. The flaw in this reasoning was not the analysis of past conflicts, but the failure to anticipate how total industrial warfare would transform the fundamental nature of armored combat. European tank battles of the 1930s involved hundreds of tanks. Pacific battles of the 1940s would involve tens of thousands. The scale changed the equation completely. German engineers made similar mistakes, producing Tiger and Panther tanks of exceptional quality in numbers far too small to affect strategic outcomes. German industry produced approximately 6,000 Panthers and 1,300 Tigers during the entire war. American industry produced that many Shermans in less than 3 months. The qualitative superiority of German tanks was undeniable. The strategic irrelevance of that superiority was equally undeniable. Japan's situation was worse than Germany's. German industry at least possessed the capacity to attempt mass production, even if Nazi leadership prioritized complex designs over simple ones. Japanese industry lacked even theoretical capacity to match Allied production. Japan produced approximately 2,000 medium tanks during 6 years of war. The United States produced approximately 50,000. The Soviet Union produced approximately 58,034 tanks alone. The industrial disparity was not merely significant, it was civilizational. Major Nakamura returned to Japan in August 1944, evacuated from Saipan before the island's final fall. He brought with him his comprehensive report on the Sherman, along with photographs, measurements, and metallurgical samples. The report was distributed to every major engineering bureau and tank manufacturing facility in Japan. The responses varied dramatically. Some engineers dismissed the findings entirely, insisting that American methods were temporary expedients that would fail under sustained warfare. Others accepted the findings but argued that Japanese adoption of American methods was impossible given cultural and industrial constraints. A few recognized the fundamental truth. Japan had approached tank warfare with the wrong philosophy, and no amount of engineering excellence could compensate for the industrial capacity gap. At Mitsubishi Heavy Industries in Nagoya, where Nakamura had spent most of his career, the response was particularly poignant. Senior engineers gathered to review his findings in September 1944. Many of these men had worked alongside Nakamura for years, had collaborated on Chiha design and production, had taken genuine pride in the quality of their work. Chief Engineer Masao Okabe, who had supervised Chiha final assembly for 6 years, studied the photographs of Sherman welds with visible distress. These welds would never pass our quality control inspection. We reject work far better than this, responded Nakamura quietly. They produce 40 tanks per day, and we produce 40 per a month. The silence that followed was heavy with unspoken implications. Every engineer in the room had devoted years to perfecting Japanese tank production. They had implemented rigorous quality standards, trained skilled workers, developed refined processes. They had created an industrial system that produced excellent tanks slowly, when they needed a system that produced adequate tanks quickly. We did everything correctly according to our training, Okabe said finally. We followed established engineering principles. We maintained professional standards, and we failed completely to understand what the war required. This recognition spread slowly through Japanese engineering circles as the war's final year unfolded. The American bombing campaign made the theoretical discussions increasingly irrelevant. By early 1945, Japanese tank production had essentially ceased. The factories that had produced Chiha tanks were being systematically destroyed by B-29 raids. The steel that would have built tanks was unavailable. The workers who would have assembled them were being drafted into military service or killed in bombing raids. The Type 3 Shinyu tanks that had been produced for homeland defense sat in camouflaged positions around Japanese cities, waiting for an American invasion that would never come. Their crews had been trained on equipment that was obsolete before it entered service, prepared to fight a defensive battle against an enemy whose industrial capacity made conventional resistance futile. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.